Okay, we're going to start section 10.1, which is on radicals. We do most of our discussion about square roots, but we will look at other roots as well. So let's start out. Question number 1 says to find the square root of 576. Now, a couple of ways you could do it. You could guess and check. Well, it must be a pretty big number that would have to be squared to give you 576. Or you can use your calculator. You should be able to find a key on your calculator that does square roots. And it's different on different calculators. I can talk to you individually about it, but there's no way I can make a global statement about that. I will say that depending on your calculator, some of them you hit the square root key, then you type in 576, and then you either hit equals or enter, and out pops the answer. Some calculators, you put in the number, and then you say what you want to do to it, and then you do equals or enter. So it kind of depends on your calculator. Another option is to use something from the handouts page called the power sheet or power list. The only problem, if you print that, you're going to get 6 copies of it. I did that originally for myself so that I wouldn't have to print so much, and I just cut it and hand it out in class. But in that one, since this is a square root, I'm going to look under the N2, which is supposed to be N squared, and I look for 576, and 576 is too big. It's not on my chart. So somebody with a calculator working, would you tell me what the square root of 576 is? 24? Okay. It is 24, and I would recommend a calculator to do that. Know where the square root key is on your calculator, and talk to me individually if you can't find it. Number 2, it says, what is the square root of 1/4? Pardon? It should not be negative. Oh, it is negative. I'm so sorry. You're telling me. There's a negative sign out in front. Thank you. All right. This says find the opposite of the square root of 1/4. So the answer will be negative. When you take the square root of a fraction, it is the square root of the numerator over the square root of the denominator. That started out being negative. It's going to stay negative. What's the square root of 1? And what's the square root of 4? 2. And there's my answer. For right now, when you're asked to find a root, it's going to be a rational answer. It's not going to be one of those long, nasty decimals that you don't know where you should round it. These are all going to work out nicely.
So it just, whenever you have a fraction, you're going to do the square root of both, right?
Yes. And I recommend that you not put, well, I mean, you could put this in your calculator. And if you take the square root of 1/4 using your calculator, you will get 0.5. Because 1/4 will change into 0.25, and then it'll take the square root. It'll give you a decimal. My math lab won't like that. So it's thinking you're going to do this in your head. Number 3, find the square root of, or the negative square root of 81. What will that be? It'll be -9. You're carrying the negative sign over 9. Now, number 4 takes us into possibly a new realm. It asks you to find the square root of x to the 6th. This is the first time in our class that we've looked at taking the root of a variable with an exponent. Now, what I'm asking you is, what would you have to square to get x to the 6th? X to the 3rd. Your instincts are good. That is the right answer because x to the 3rd squared, do you remember from Math 307 or from a previous math background that when you have powers to powers, you use the power rule, which says to multiply those? Well, that being said, What do you think you're always going to do to an exponent when you take the square root of it? Divide it by 2. Now, why 2? There is an implied, what we call an index right here. And I'm sorry, I was hoping that my pink circle would be there. I can try to get it. I'll probably, oh, there it is. Come here. No. All right, no, that didn't work for me. All right, so I have this little micro dot instead of a nice big circle. There is an implied, not written, index right here. And when it's square roots, the index is a 2. That says that the answer to this is whatever it takes to square it to get this quantity. The index is 2. And so what you did, not even realizing it, was you divided the index into the exponent. And it might be crossing your mind, what if it doesn't go in evenly? And that's another lesson. All right, let's go on. Number 5. It says, what's the square root of 16x to the 6th? Well, we can do it factor by factor. What's the square root of 16? And the square root of x to the 6th? X to the 3rd. Number 6. It says, find the square root of 17. And right away, we all know that's not a perfect square, so let's read the instructions. After where the answer box is, it says, round to the nearest thousandth if necessary. Type a capital N if the square root is not a real number. So using your calculator, I'm getting mine out. I take the square root of 17 and I get 4.123105626, and then it's going on. What did the instructions say? Round to the nearest thousandths. Tenths, hundredths, thousandths is the 3rd place. What does the 1 tell you to do? Keep it the same. This is approximately 4.123. If you round incorrectly, or if you round to the wrong place, it'll count it wrong in my math lab. It most probably will say that little comment, your answer's correct, but. Okay, so, and you don't want that comment. So make sure you know how to take a square root with your calculator. Number 7, same instructions. It says, what is the square root of 45? It says to approximate it to 3 places. So if you'll do that with your calculator. On my calculator, I got 6.708203932 if I copied it down correctly. If I'm going to follow the instructions, I'm going to round to 3 decimal places. The 2 tells me to leave it as is. This is approximately 6.708. Which means that if you cleared your calculator and you took 6.708 and you squared it, you would get something really, really close to 45. It wouldn't be exact. I got 44.9972 something or other. So it's close. Number 8. Now, we're going to leave square roots for a minute, and this one says find the root, and it has an index of a 3 sitting up there, right in the little crook of the radical sign. And 1,000 in here. When the index is a 3, it's called a cube root, and it wants to know what would you have to cube to get 1,000. What do you think? 10. Now, let's see if is 1,000. Nope. So far, this little power sheet has been, oh yeah, it's on there. I'm sorry. To use the power sheet, if you look under n to the third, these are what we call perfect cubes. If you go down the column n3 and you find 1,000 and go to the left, its cube root is 10. So sometimes this is faster than a calculator, sometimes not. Now, the cube root function on your calculator, I would need to talk to you individually. For those of you who are using TI 83 and 84s, it is under the math key, if you hit math, and it is the fourth option down, and you hit enter, and then you type in the number. Okay, now that's just for everybody using that particular calculator. You're using another one. Some have a cube root key, some have what's called an en root key, where there's an n there. And what you have to do is type in a value for n first, and then activate that function, and then type the radicand, which is the guts of the radical. But I would need to talk to you individually about your calculators, and I'll probably leave some class time to do that. So, cube roots. Number 9. What is the cube root of negative 125? Well, do you know what the cube root of positive 125 is? It's 5. So what would you have to cube to get negative 125? Negative 5. If you take a cube root of a negative radicand, and radicand is the name of the inside number, then you will get a negative value. Now, something that didn't happen to us, I want you to notice, because it could happen, if I ask you to take the square root of negative 25. Now, I didn't put the negative on the outside. We've already seen that. We know that means the answer is negative. What can you square to get negative 25? Nothing. At least nothing real. Because if you square 5, you get positive 25. If you square negative 5, you get positive 25. This does not have a real answer. There's no real answer. In MATLAB, if that should happen to you, it will have you type in an n. So you can't take the square root of a negative radicand, but you can take the cube root of a negative radicand. And your calculator knows that. If you ask it to do it, it will come back with an error message. If you ask it to... Pardon?
Came back with a 0.
Yours came back with a 0. Is there an E on there somewhere on the screen? Take the square root of a negative 25 and see what your calculator says.
Yeah, it has E and then 0.
Okay. One of them said domain error. One of them said an E with a 0. The E is abbreviation for error. So it should give you some kind of little message that you can't do that. All right. Let's look at number 10. You can see there are a lot of questions, but these go pretty rapidly. What's the cube root of x to the 24th power? So what I'm asking you is, what would you have to cube to get x to the 24th? So I'm not taking the cube root of 24. I'm asking what x to what power quantity cubed would equal x to the 24th?
It's not a whole number.
Not for the cube root of 24, but it is for an exponent. And the answer is x to the 8th. The rules are different when you're dealing with exponents as opposed to a rational number. Because x to the 8th cubed, you'd use your power rule, and you would get x to the 24th. All right, would you tell me what is the rule that you should remember when you're taking roots of variables with exponents? What's the rule? Divide by the index. Exactly. Divide by the index. And the only time the index is not written is when it's a square root and it's implied to be 2. All right, let's look at 11. What is the cube root? And I'm sorry, sometimes when I get to writing faster, my radical signs deteriorate, and that's a pretty bad one. Negative 343x to the 6th. Cube root of this. All right, can you take the cube root of a negative 343?
Yes.
Yes. And what is the cube root of 343? Okay, it is negative 7. You can do that on your calculator, or you can use the power table. Now, what's the cube root of x to the 6th? X to the 2nd. Dividing 3 into 6. Is that okay? Remember, exponents have their own rules.
I don't know why I wanted to just leave it as X.
Well, I don't know why either, but don't. All right, here's a good one. What's the 4th root of 81? Now, calculators are not, in fact, I've never seen one that had a 4th root key. There's an nth root key where you type in a 4 before you hit that key, but you can use the power table. What would you have to raise to the 4th power to get 81? 3. So this is a practice doing roots other than square roots, but we will not spend much time in this chapter on anything except square roots. Number 13. It says, what is the 4th root of negative 1? Error. Okay, he got an error message. I said earlier that you can take the cube root of a negative, but you can't take the square root. Well, we can extend that idea. You cannot take an even root of a negative radicand. So this is, according to MATLAB, it would be an n. So if I want to write down a little summary, and I think this is something that when you study math, you should be very tuned into. Periodically, you come up with conclusions, and so you want to summarize those. If you have a radical and you have a negative inside, if the index is even, you get no real answer. If the answer is, if the index is odd, you get a negative answer. So you can take odd roots of negative radicands, but you cannot take even roots. All right, let's look at 14. It says, what is the 5th root of negative 1024? Oh, it's got another negative? Yes, it does. Thank you. Okay, so this negative, I'm going to drag along to the answer. Let me make that arrow actually go to it. All right, now, 5th root of negative 1024. Now, if you figured out how to do 5th roots with your calculator, fine. Otherwise, look in the n to the 5th column for 1024, go all the way to the left, and you get 4. And it's going to be negative 4. Now, I've put it in parentheses just to try to make sure you're clear. This outer negative sign came from in front of the radical. It really could be read opposite of the 5th root of negative 1024. So it's going to be the opposite of negative 4, which is positive 4. If this 5 had been an even number, I just would have had to stop the problem and say, it's not real. I can't take an even root. But I did take the fifth root of negative 1024 and got negative 4. The sign out in front said, and give us the opposite of, which turned out to be positive 4. 15. Let's figure out the fifth root of x to the 25th power. What's the rule with taking roots of variables with powers? Divide. So what will I get? X to the 5th. And is it right? Well, is x to the 5th raised to the 5th x to the 25th? And the answer is yes. So you can see that this first section is just kind of an overview section, making sure that you can take different roots of different radicands. 16. What's the square root of 49x squared? 7x. $17. What's the square root of x minus 3 quantity squared? Well, let's not make it any harder than, right now you're going, ooh, do I need to multiply that out? What do I need to do with it? What did you do with, on number 16, what did you do with the x squared? Didn't you just divide the implied index 2 into it? Do the same thing here. You're going to get x minus 3. If you take the square root of something squared, you are undoing what it says to do. Squaring and square root are inverses. So the radicand just pops out. All right, let's look. So don't square the binomial if you were tempted to do that. Number 18. It says to find the square root of x squared minus 8x plus 16. All right, let me give you a hint. Number 17 is a hint. 17 is a hint to 18. You cannot take the square root of a sum or difference by going through and doing it term by term. You cannot do that. You could do it with products, but not with sums and differences. So, do you notice anything about this trinomial? Yes, it's a perfect square trinomial. Congratulations. A lot of people don't recognize that. And I'm hoping, though, that you will after I stomp my foot and make a big deal about this. All right, if this is a perfect square trinomial, then it can be factored into something squared. Well, what are the factors of x squared minus 8x plus 16? Yes, it is x minus 4 times x minus 4. If you wanted to, you could do that. Whoops. I messed things up. X minus 4, which can be written as x minus 4 quantity squared. And now, what's the square root of it? X minus 4. Because when you take the square root of something squared, it's as if you did nothing to it. Okay, so I'm going to write a little note. Perfect square trinomial. When you're doing math lab, I would have my notes sitting there because you can bet that number 18 in math lab is going to be like that. Number 19, getting close to the end of 10.1. Find the square root, the negative square root of 36. Can we do that? Yep, and it is negative 6. The negative sign out in front just drags along. It's as if I'm saying what's the opposite of the square root of 36. Number 20. Put several ideas together. What's the square root of 36, x to the 6th, y to the 14th?
Six to the third, y to the seventh.
All right. We took the square root of the rational coefficient 36 and got 6. We took the square root of x to the 6th by taking half of its exponent, x to the 3rd, the square root of y to the 14th by taking half of its exponent. And one last question. All right. What is the fifth root of negative 243 x to the 10th, y to the 15th? Can you take the fifth root of that radicand? Yes, because you can take an odd root of a negative. Using your power table or being really good with your calculator, 243, what is the fifth root of 243?
Negative 3.
Okay, it is, this one's going to be negative 3 because the odd root of a negative radicand will be negative. Now, what's the fifth root of x to the 10th? X to the 2nd and y to the 3rd. All right, I do want to mention one thing that didn't come up and won't come up in Math Lab, but it will come up later on in algebra. Let's talk about square roots for just a minute. Remember this. If you take the square root of, let's say, 25, you get 5. That's the principal square root is the positive square root. If I want to know the opposite, then I'll put that symbol out in front, and that would be negative 5. If I want both, because 5 squared gives me 25, negative 5 squared gives me 25, I can use a joint symbol. It's called a plus or minus symbol. If I put that out in front of a square root, then I want both answers, plus or minus 5. MathLab does not have that symbol, but you will find it in algebra. You'll find it in chapter 11, actually. It's called a plus or minus sign. And it just says there are 2 square roots of 25. If I don't put a symbol out in front, I want the positive one. If I want the negative one, I'll force it by putting a negative in front. But if I want both, I'll put the joined symbol. Okay, so that won't happen in MathLab, but I wanted you to see it. Okay, I'm going to call this lesson done, and we're going to go on to 10.2. Yes, yeah, if you didn't pick up 10.2.